All right, good morning, everybody. Good morning. Yeah, thanks, Tim, for the introduction. So today's panel is focusing on alternative building materials. And so we have about an hour, so the plan is roughly each panelist is going to speak for 15, 20 minutes, and then we're going to, I have a couple questions to throw at them, and then we're going to open it up to the floor. So for introductions, we're very lucky today to have Heather Campbell from Wykander Wise, Morin Cork Flooring. Heather is the Eastern Ontario sales representative for Morin Cork Flooring. She has over 6 years of experience in the flooring industry and another 10 years of home decor and interior design experience as well. She now solely focuses on green and sustainable flooring and wall solutions that are made of cork. With the help and support of her partners in the flooring industry, her goal is to bring sustainable and attainable options to all clients. It's great. I think what's interesting about today's panel is it's always great to talk about materials that could be introduced into any new construction or renovation project, as opposed to whole wall assemblies like straw bale or rammed that kind of thing. So we also are lucky to have Garrett Johnson here today. Garrett recently completed a research project, developing rigid insulation from annually renewable agricultural biomass with the creation of novel, non-toxic, and bio-based binders. He was successfully able to produce a viable product with a blend of corn stover, switchgrass, and hemp fibers. The project also produced viable formulations for an OSB panel product made from hemp hurd or corn stover under the mentorship of Evolve Builders Group, who partially funded the research project. Garrett will be starting a company called 100 Year Materials. We'll focus on developing and producing building materials from non-toxic, carbon-sequestering, annually renewable resources, beginning with rigid insulation and blown-in cellulose, followed by agricultural fiber, OSB. Great, and we have Chris Bailey. Dropped in the sky. Chris, can you tell us a little bit about yourself?
I run a construction company in Perth, and I run a construction company in Perth, which is just inside of Ottawa, and we, try to use as much natural materials as possible. So over the years, we've done a little bit of everything, like different stuff: straw bale, straw panels, straw clay panels, and I guess hempcrete is really our focus right now. So that's it. Who starts?
Heather, would you like to start? Sure.
Hi everyone. Hi, I'm Heather. I'm the sales rep for a company called Morin Cork Flooring. Our brand that we carry here internationally is Wykander Wise. We're offering some amazing cork products that I think a lot of people haven't seen before. A lot of people associate cork flooring with grandma's cork from the 50s in her kitchen that has maybe failed over the years, but we've really come a long way since then. The company that I support is Amardine, and we've been in business for over 150 years. We are the largest cork manufacturer in the world. And a disclosed market share of 82%, disclosed market share of 62%. I can explain why personally if you want to. But the largest aspect of our business and how we started was actually cork wine stoppers. So that's still the largest aspect of our business. We sell 27 million cork wine stoppers a day. So just a few bottles of wine to get us through the weekend. And our flooring business was actually born out of a need to have a cyclical business within our umbrella company, because when you're producing natural cork wine stoppers, it creates 70% waste. So as a company, we're looking at that going, well, we have all this, what are we going to do with it? So the flooring industry was born. We've been in business there since the 70s, so over 50 years at this point. And we do take being green very, very much to heart, to the point that we siphon away all of the dust created during our manufacturing process and burn that as biofuel. And that equates to about 60% of our total fuel usage. And then we just finished putting 2 million square feet of solar panels on top of our production facility in Porto, in Portugal. So we're hoping to be off-grid within the next few years. And we're also planning on being completely plastic-free within the next 10 years as well. We've just eliminated all the plastic from our packaging and have moved to recycled boxes for our flooring as well. So we don't just talk the talk, we definitely walk the walk. In terms of our flooring products that we have here in Canada, we have an incredibly wide range. Things from glue-down cork that you probably associate with cork flooring to amazing, amazing click products that can suit pretty much any need within a home. Basements, bathrooms, kitchens, and everything else. Everything in our lineup carries a lifetime residential warranty and a 10-year heavy commercial warranty. And I do emphasize the heavy because we've done quite a few commercial projects like bars, restaurants, hospitality, medical, and things like that with our products. And they just keep overperforming better than we could have ever hoped. We are in the midst of launching some new products that I think this crowd will appreciate the most. We've just launched the first biodegradable floor that's made up of cork, bagasse. If you're not familiar with bagasses, I guess you're not moonshiners on the weekend. So it's the leftover material from the sugar making process, and then a little bit of stone, and that's it. So just 3 ingredients. And it's a beautiful, beautiful product that comes in wood visuals, cork visuals, and stone visuals. We know that not everybody loves a cork visual, so that's why we offer others. And yeah, it's a 29 board cut and repeat, a 30 mil wear layer, 7x60 plank, 9 mil thickness, click product, and it's just absolutely gorgeous and amazing. And we're really trying to push that into the market. We're trying to go after engineered hardwood and that sort of realm with that product. But we also just introduced a new product as well, where we're trying to be the SPC killers. So we're trying to take down the LVT world of cork, and that is a cork product mixed with PET, recycled plastic, stone and iron, and that is 100% waterproof as well, as is everything with cork, because cork is naturally waterproof. Who here has seen a wine bottle leak? No one? Okay, perfect. And that's also completely stable as well, can go into pre-season spaces, which is amazing, and hold it beautifully. And that is priced at the LVT price point as well. So again, we're trying to really bring products to the market that's going to suit any budget, any need, and pretty much go into any space. So although I can't show everything that we carry on the 2 little tables up at the mini trade show, I've got lots more that if there's something that you're interested in, by all means let me know. Because we are the manufacturer, there's very, very little that we cannot do, okay? We have the production facility, we have manufacturing. We now have a $12.5 million digital print machine that was made exclusively for us by a company in Germany called Hyman. You can all off the bat after I leave, it's fine. And so really, there's nothing we can't do as long as the project size makes sense and the price point makes sense. So, yeah. And just to continue on with the green story for us, we have gone so far as moving facilities closer to the Montado, the forest in Portugal, to eliminate transportation costs and fuel usage. And we continue to keep growing that. So when you want a green product, please think about cork. It's not the cork that you remember from a few years ago. Even for us as a company, the cork we were selling 10 years ago, we don't make anymore, right? The wear layers, the durability has really, really come a long way. So, yeah.
I have a question.
Yes.
Okay, so when I'm in Beam, if I were to choose cork inserts into a Nexam wall, like a Nexam block foundation wall,
Okay.
an ICF, then I notice all of a sudden the carbon storage goes way down. So cork is carbon storing material. And I was just wondering if you could speak a little bit to that.
So if I'm interpreting what you're saying correctly, so yeah, so cork does store carbon on its own. The carbon capture of the cork oak forest is incredible. It also will store carbon within the home as well. It's a material that doesn't want to release things. It's an air purifying system as well. So within a space, it kind of equates to having like lots of plants in your home. It can also be used in insulation purposefulness as well. We do have insulation products. I don't personally sell them, but our company does. So if you're talking about using insulation on the wall, we can do that as well. So, yeah.
I think I didn't drink enough coffee or something this morning because I said the carbon storing goes way down, but what I meant was goes up. Like down is good.
Is that compared to the rock salt?
Yeah, just in that assembly.
That thing
But
goes
basically,
down.
cork has a lot of carbon storing capacity, storing a lot of carbon.
Right.
Because when those trees were growing and the cork was growing on the outside, it was sequestering carbon. That carbon is now locked in the cork.
Right. But its footprint would be less than the rock salt that they would usually.
Yeah, absolutely,
Right.
absolutely, yeah.
Cork trees are amazing.
Yeah, these are amazing.
It's cold.
Okay.
It's a variety of cold.
Yeah, you can grow a cork oak tree in Canada. You'll never get cork out. We don't have a warm enough climate. So, yeah.
Well, maybe someday.
There's a place
I
to visit
kind of like where this is going, because we need to more minutes, there's 15-minute slots, so we'll use those up to ask specific questions, and then we'll kind of get back to our program. So, yeah, Anna at the back.
Yeah, is there any project that you're aware in Canada where cork has been used as a cladding?
Oh, like on the outside? It's a great question. Unfortunately not, not that I'm aware of at the moment. Again, this is something that we do as a company as well. Our showroom facility in Porto is completely covered in cork panels from the outside and on the inside. I was telling someone yesterday, I can't remember who it was, my apologies. Yes, thank you, Chris. That we have a auditorium in our showroom that's actually underground. It's underneath our production facility above that has forklifts and machinery and everything else going up over it at all times of the day. We run our production facility for 24 hours a day, so it's constantly going. And the auditorium is encased in cork. And when you walk into the auditorium, it's almost eerie how quiet it is, but also comforting. It's very strange. It's a very, very strange feeling because it's just so quiet. You can hear a pin drop. So yeah, we would love to bring that here to Canada. I've had a few builders get in touch with me in terms of using it for insulation material as well as a cladding. It's an interesting material because it's just cork. So when you heat up cork, it emits a natural resin called sublim that holds itself together. So we don't need to add anything to the product to make it an appropriate material for exterior, interior, or in between walls as well. So, yeah.
I'm curious to hear more about what the process looks like from the point where it's on the tree in the forest to the point where it's entering your.
Yeah, for sure. So we harvest cork between May and August every year. It's the highest paid agricultural job in the world. It's actually illegal to cut down a cork oak tree in Portugal. You'll get tossed in jail and with a €25,000 fine, so don't do it. Yeah, so we harvest a cork every 7 to 9 years. It takes about 25 years from when the tree is planted to get the first harvest out of it. The first 2 harvests aren't appropriate for cork wine stoppers, so those 2 harvests go exclusively to our flooring and our composite business as well. And then after that, it depends on how the cork performs. If it's thick enough to go to the cork wine stoppers, it goes to that. And then again, we take that waste and use that for our flooring business as well. The trees last in terms of harvesting for about 200 to 250 years. After that, we just leave them alone and they do what they gotta do. We are in the process of planting 1 million trees as well as a company. We own 18,000 hectares of forest, but we're adding to that. And then from the harvesting process, that all gets moved to whatever facility makes sense for that cork. So in southern Portugal is more focused on our wine stopper production facilities as well as our cork composite facilities. Our flooring facility is in the north. Now keep in mind Portugal is a very small country, so To get from the south to the north is about 3.5 hours, so it's not too bad. And then it sits outside in our open air facility. Our facility is not closed in. There's just large openings everywhere because it's Portugal. And it sits there, dries out, and then depending on what we're doing with it, it'll either get cooked in a steam bath and then go from there to either create a visual, because all the visuals you see of our pork products that look like pork are all a thin veneer, or it'll get ground up, heated, and into sheets for underlay, overlay, insulation, things like that. Or they get burned to create visuals. I say burned, pork doesn't actually burn, it just kind of smolders a little bit, and then that's it. So yeah, it really depends on what's going on with it, but yeah, it's a very, very interesting process. It's all done by hand, harvesting the pork. There's no health and safety involved, or OSHA here in the US. Yeah, it's very, very cool.
So the harvesting is like it's being peeled?
Yeah, it's literally peeling off the tree. So, and this is why it's a very expensive job to do. You learn to hear the cork. It will tell you when it's ready to let the cork go. And then you're making essentially slits down the tree to then peel off the cork that comes off in one large chunk. I have videos.
Thick, that chunk you're peeling off?
So it depends on the age of the tree. For younger trees, you're looking at probably about 2, maybe 3 inches of bark and cork. For older trees, you're probably looking closer to 4, 5, 6 inches of thickness. But it's disgustingly light. So you see videos of these guys carrying literally tree lengths of cork bark on their shoulder, like it's air, right? And because it is such a light material, so yeah.
Is it the forest? Is it like a monoculture, and how do you deal with pesticides?
Yeah, actually, great question. So yeah, the Montado is its own ecosystem in itself, and again, this is why it's very important for us to not harm the forest in any capacity. There's animals in there that you would never see anywhere else. It's actually, if you look at a map, the Sahara Desert hasn't reached the Mediterranean Sea because of cork oak forests. It maintains its own green ecosystem. So for us, we have a very specific amount of trees that we will harvest every year. And again, we're not harming the tree by just peeling off the cork. It actually helps to elongate the life of the tree by doing this. And the process of going in and harvesting the cork is very grassroots in the sense that there's no big machinery. It's, a family with a pickup truck and a wooden ladder, and that's pretty much it, right? So we're not harming an ecosystem, and the forest is a forest, right? It's not this manufactured row by row set of trees that we're going in and maintaining. It's a natural forest that we add to, we do not detract from. So, yeah.
A couple of things that came up out of that. One is, how do you know that it's not harming the trees? Do those oak trees naturally shed their bark, or is that a process that they go through for renewal? Or?
Yeah, so yes, if you were to leave the cork oak tree alone, it can't really shed itself because you need to have a relief cut in there to let it go. The smaller branches, because they're more prone to damage by animals and things like that, will drop off. But it shortens the life of the tree. We've left trees alone and haven't touched them before, and we notice that they die off a lot quicker than when we're removing the cork off of them. It allows for the regeneration of the trunk of the tree and allows more light and air to get into them. We do it at a specific time as well, where it has enough time to regrow to protect the tree from cold in winter. I say cold because it's Portugal, like really. They complain to me when it's like 10 degrees. I'm like, seriously? Really? But yeah, so we're very cognizant of that for sure. Yeah. Great.
Thank you, Heather. Yeah, that's super interesting. So there will be time for more questions, but let's keep on our program. So next up, Garrett, can you tell us about what you've been up to?
Yeah, for sure. First off,
Sorry.
I'll pass around some samples for everybody to touch and feel. So it makes more sense. So I may have misunderstood the premise of the panel discussion and prepared a PowerPoint presentation that is a shame to waste. So how do I need some help with this? So yeah, my name is Garrett Johnson. I work as a designer at Evolve Builders Group, and they've been super supportive and helpful on very many levels, helping me develop these products. And it's been a big journey and established kind of a new focus for the foreseeable future, which is pretty neat. The project started out as a research project at Mohawk College, funded by Evolve and a research network. And so yeah, we're going to mainly talk about a rigid insulation from corn stover, switchgrass, hemp, and a non-toxic bio-based binder or adhesive. I'll give a brief overview of this. Embodied carbon, I'm sure most people in the room know more than I do about it, but in case anybody is uninitiated, embodied carbon is, or operational carbon are the emissions used to live in your house, heating and electricity, those associated emissions. And embodied carbon of materials is everything else from extraction, transportation, manufacturing, installation, and disposal. There are various degrees of embodied carbon for different materials, and we're going to focus on rigid insulation because that's what the product is. This is a graph of a bunch of different very common insulations, and it's a graph of the total greenhouse gas emissions, so embodied and operational carbon, over 30 years. You can see the top line there. It has that sweet spot in that trough where, depending on how you're heating your house, whether it's a heat pump or natural gas, there's an optimal amount of insulation to add to your house to reduce your overall emissions. And then if the insulation you're adding has a high embodied carbon, such as the older and some of the newer formulations of XPS, extruded polystyrene, that pink hard foam, or mineral wool from Roxil, you end up adding emissions to your overall building quite quickly. So in a heat pump scenario, they're showing, what is that, like R5, 6 at the optimal level, and then the more you add, you're actually adding to the emissions to the point where it would have been better to not add the insulation. And obviously it's less pronounced with natural gas because your heating source is so carbon intensive. So we're trying to make something that doesn't do that, doesn't shoot up the more you add. And you can see all of these other greener insulations like EPS or fiberglass back insulation, blown cellulose. They plateau at a certain point, but some of them you keep adding, and it does, have a slight increase, but you have diminishing returns the more insulation you add to your building. And those first two scenarios get you, those first two insulations that shot up like a hockey stick, they get you this scenario, which I'm sure many of you are familiar with, where you can have a high performance home. You can see on the top right panel there that was built with really good intentions to try to limit climate change, and because you're not paying attention to your materials, you're actually doing more harm than good. More harm than if you had just built to code and heated with natural gas. And you can see the embodied emissions of that building in the top right, that orange block, is higher than the, I can't remember the timeline here, looks like 30 years, then higher than the 30-year emissions of a natural gas code-built house. So thanks Chris Magwood for this information, stole it from one of his presentations. And this is why we have products like Gutex, Sonoclimate, Eco4, and the new company Timber HP. They all produce wood fiber, rigid insulations. Gutex and Timber HP use petrochemical binders, polyurethane, and I think the MPI or whatever. And then the shouldn't say whatever in a presentation. It's probably bad form. And Sonoclimate, which I think they use starch as a binder, which is pretty interesting.
It's an old product.
Yeah. Yeah. And then we have these newer products from commonly known as hemp wool, which are blends of hemp bast, the fiber from the outside of the hemp plant that's used for textiles, and they blend it with polyester and then heat it, and the polyester sort of melts and binds everything together. And Nature Fibers is in Canada, Hempitecture is in the United States. And similarly, we have these other new materials that Timber HP making wood fiber cellulose, Nature Fibers making wood fiber cellulose. Same process as newsprint cellulose. And so we're trying to sequester carbon with the materials we're using by taking advantage of plants, which are solar-powered carbon capture machines. And if you can get the carbon sequestered from the plant growth to be greater than all of the CO2 emitted during production, transportation, installation, then you can have something that's considered carbon negative with that biogenic carbon sequestration. So that comes from natural materials and then some green energy used to produce the material and energy non-intensive processes. So we're trying to get something like this where you start out negative and you have that steep curve as you have that the very necessary amounts of insulation to keep a building warm, and then you can keep having an environmental benefit that keeps going down as you add comfort to your building, and you have a positive environmental impact and high performance. But all of these products so far have been wood fiber, and wood is great, but there are other forms of biomass in the world. I see that I accidentally deleted the slide that shows how much, but it said 3.12 million tons of biomass residue, they call it, available for use in Ontario right now that is not being used. So 3.12 million tons that converted to CO2 when it decomposes is something like 5.8 million tons of carbon dioxide going into the atmosphere. And there are no agricultural fiber rigid insulations. Again, wood is great. I don't want to see full trees going into chippers and turned into something that you can make with fiber very similar, lignocellulosic fiber that we're throwing away right now. So up until recently, there was no answer to that, but in the United States, I noticed Hempitecture is releasing these products in the next year, maybe. Well, who knows, but it's coming soon. So they have rigid insulation, and then seems like thick sheathing and maybe an OSB product. And then there's this other company from the States, Planted, making elephant grass OSB. They recently got a bunch of funding to make a plant. But we still have no Canadian non-toxic carbon negative rigid insulation. And well, so I mixed up the order of my slide. This is what I was supposed to talk about forestry. Here's the 3.12 million tons of crop residue here. And here's a graph showing that when you're harvesting that biomass from a crop, you're sequestering quite a bit more carbon per acre of land use than a forest even. A forest sheds a lot of its biomass every year, grows slowly, and forests are great, but maybe not as good at sequestering carbon as the sources that we're already using. And I started off the project thinking that I would create insulation from hemp, all of those other great companies doing that. I had a conversation with Chris Magwood, who suggested that maybe I use what's available instead of shipping in something from the West, introducing new economies that don't really exist here right now. And so I switched to primarily corn stover, which is the biggest source of biomass in Ontario, in the world as well. So this is grain corn. It's different than the sweet corn that you eat in the frozen food aisle, or the corn on the cob husks. And I had a conversation with Ontario Biomass Producers Cooperative, who turned me on to some perennial plants that remediate soils. So topsoil loss is a major climatic issue, and planting switchgrass can help with that and aerate soils, add carbon to soils, because they have multi-year root systems that grow. And we're trying to avoid these common binders that are used throughout the building industry. Urea formaldehyde, phenyl formaldehyde, MDI, super common. That's what is used in plywood and rock wool insulation, different building materials. And that's where the research project landed, funded by Evolve again, and this research network. We're trying to develop non-toxic bio-based binders and process those fibers into something usable. So it was a lot of work, many hundreds of trial and error to develop this binder from lignin, which is the glue that holds together most plants other than cork, which is suberin. And we were successful in making a waterproof, durable, bio-based, non-toxic binder, and got something like this, which some of you are holding. So I think this is actually an older version of the presentation, unfortunately. I did have an R value there. I just tested it this week, actually. The experiment is going right now. You can go look at it. I built 2 heat boxes that have a little heater in a chamber, and then 2 thermometers just above and just below an insulation, measuring the difference in temperature. And it turns out to be much better than I expected. I was guessing it was going to be somewhere near Gutex, which is R3.6 per inch, but it's performing better than EPS, which is officially 3.75 per inch. So it's going to be somewhere in that range of 3.7, 3.8, maybe 3.9, which is great. Just other photos.
Yeah. Oh, it is, yeah.
What's that? Oh, yeah.
We only got half the. My bad.
And in the process of processing the fibers, we end up creating a lot of fines, which are essentially just cellulose fiber. So we can harvest those with dust collectors at each machine processing point, and then use that as blown-in cellulose insulation that's actually a waste product or byproduct, whereas most commercially available cellulose is no longer recycled newsprint. It's a new product because there's not enough fibers being recycled to turn into the demand for cellulose insulations. They're all being turned into Amazon boxes. I've heard from trusting sources. People you should trust. And so we also developed some some OSB formulations. This shown here is hempert and another non-toxic bio-based binder that's heat activated. And we're experimenting with different fibers. So shown here are miscanthus, cornstover, miscanthus, hurd. And future plans would include turning this into, laminating them together and turning them into a product similar to Zip System. So laminate that OSB to the rigid insulation, and you can install sheathing and insulation at the same time. I've also experimented with the density of that sample that I'm passing around, and it's possible that playing with the density could end up just creating something that you can use as sheathing as well. Not going to make any claims, but maybe it's possible. So yeah, that concludes the presentation.
Amazing. Thanks, Garrett. That's super inspiring and exciting. And in case you haven't seen Garrett's setup over at the trade show, he has everything displayed there. All right, so Chris, thanks for... Okay. All right, any questions for Garrett? Lots.
Yeah.
All right, Tim.
So you're, and this maybe as much for Ben as it is for you.
Yeah.
So setting up, like, where are you at with getting things going? Is there an investment opportunity here?
I would say, so yeah, I did add another slide that got lost in the fray. We got a bit of funding from the Grain Farmers of Ontario through their Grains Innovation Fund to tool a pilot plant, basically. So buying some of the expensive equipment needed to process the fibers at any sort of scale. We're going to be purchasing, Kijiji equipment, and we would likely need 20 times the amount of the grant to do it right, but we're going to make it work with whatever we have. An investment opportunity, I would say that there will be, and that I don't want to take anybody's money right now. Yeah.
But so what scale are you shooting for?
Yeah, so in the next year, we're hoping to be able to create full-scale panels. Full scale, to me, right now means 2 foot by 4 foot, 1.5 or 2 inch thick panels that can be used for building insulation, to do a couple pilot projects to have a proof of concept, attract more funding, and maybe get some alternative solutions, approvals, and that kind of thing. Yeah. And then beyond that, hopefully scale up to an actual production facility that can shoot out material at an economic rate. In theory, it shouldn't be all that expensive. Cornstover is really, really cheap compared to hemp fiber, for example. It's like 30 times cheaper. For example, I can't remember what the per ton cost I was paying for hemp bast, but it's 63 cents a pound, and the Cornstover was around $150 to $200 per ton. So big difference.
Yeah.
So in theory, it could be very, very cheap, which would be great. But. And the lignin is also, it's a byproduct, it's a waste product from the pulp industry. It's very expensive if you're buying small amounts, and very cheap if you're buying large amounts, because it's worth the pulp mill's time to send you a big tote of lignin rather than paying somebody to take off a kilogram at a time, pass it around. Yeah. Dave?
The second sample that you had was a more dense form.
Yeah.
What's that?
So that second sample I was passing around, that would be the hemp herd OSB. It looks a bit different than what the samples I had on the screen looked like. They're a little bit darker, and that's because it's a different source of herd. I think the one that is being passed around is from Terra Fiber, and they have a lot of green stems and things like that mixed in, and the one on the screen was from Canadian Rockies Hemp Company, and that was very. They must screen their herd more or something, and they don't include any of the green stuff. But when you heat up those green stems with the binder I'm using, it turns brown. Any other questions? Oh, sorry. Yeah.
What is the binder that you're using?
It's so we're using two different binders. The one for the insulation is based on lignin, and I don't want to get into the other combinations going in there, but all the sources can be sourced from bio-based raw materials, and lignin is the biopolymer that holds together the cellulose in plant cells.
And is there any sort of fire rating for the panels?
There's no fire rating right now. I'm doing all of the testing in little boxes at home, but I have held a lighter to samples, and they burn. They'll smolder. It's hard to get them to catch a flame. It seems a little bit better than Gutex, for example. I think because of the polyurethane binder used in Gutex, it'll burn more and hold a flame, whereas I had a hard time getting my material to hold a flame, but it'll smolder for sure. Cool, thank you.
Great, well, thanks for jumping in here, Chris. I, for one, am excited to hear more about Hempcrete and your supply chain and what you've been doing and how big your roles are and all kinds of things.
And you can this could be a teaser because you're gonna.
Well, that's sort of the problem, is that I'm presenting next, and that's going to be one long I wasn't.
Anything else?
Well, I was thinking about telling you all a story.
Okay.
On Tuesday, I went to a project that's a house that Dawson and I built, well, with a lot of other people, obviously, in 2012, and it's a straw bale with post and beam, I guess you'd say, like embedded in the straw bale. And this house has been bought and sold 4 times since it was built, which is kind of weird. But so the new homeowner was away and then came back, and they're lighting wood stove, and it was sort of smoky, and they weren't really paying attention. They thought it was just backdrafting, and they went out to leave, and they took their coat off of a coat hook, I guess, and it burst into flames because there was some electrical thing going on behind it, and the whole wall was basically on fire, but you couldn't see it. Like, he didn't know. It was just smoldering in the wall. And so then, I don't know, whatever, he called the fire department. They came, they put it out and tore that whole wall out. But interestingly, the fire chief was like, this house would be gone if this was not a straw bale plastered house. And I don't know, it was just, it's always interesting to see a project, well, in that situation it's not good, but you know, so they asked me to go look at it and give a quote to fix it, basically. But you know, all the timber is not fine, but it's not bad, really. And I mean, there's an engineer report saying that it's all compromised and has to be replaced, but it's still holding up the roof, and it's structurally doing its job right now, which is, I don't know, it's just interesting to see how buildings perform under a situation like that. I don't know what happened really, like, well, it's an electrical fire, but we were trying to remember if the homeowner wired it, or I don't know, it's all sort of one of those, yeah. But also I bring that up because it was one of Camelback's last projects, like, I don't know, a lot of people that could be in this room, but they're here, but they were there too, you know, so there's, anyways, a lot of people were sort of a little bit invested in that project.
So did it get hosed down?
Yeah, the water damage was the problem, basically, you know, and so they drilled holes all around the whole house, like in the bottom of the wall and to, I don't know, let it breathe out, I guess, and do you remember what the plaster was there?
Clay inside. Cement line outside, but still, I don't think it was straight line. And he was the building envelope engineer,
Right.
and he was willing to take that risk. That was quite contradictory even then. Yeah, I'm not sure. I don't feel like it was straight line somehow. I think, and anyways, it seemed risky, cement line on the outside, earth and inside.
Right.
But I'm pretty sure
The plaster was in perfect shape, the homeowner said, until the fire, and then now it's still really in great shape, honestly, but just has some cracking in certain spots, like way far away from where the fire happened, from the water. Like this is in January, the fire, so, you know, it's water and cold, and there's a lot of water, basically. But, yeah, I don't know, it's just interesting.
Absolutely.
I don't know. Any questions about that?
How does the remediation work for that? Do you have to like replaster the
Well,
thing and replace valves?
yeah, I have to talk to them about that, sort of. They would like it to be replaced with straw bale, but I would like to do it in hempcrete, just because it's kind of neat to combine those two all in one spot, and it'd be more interesting for me, basically, but, yeah. So I don't know, we'll see what we do. But, yeah.
Yeah.
But it would have to be all plaster regardless, like you'd have to sort of blend those plasters together and sort of,
And then like the water damage could be in multiple locations, so do you like do a moisture test?
it'd be good to sort of go around and just check the condition of the rest of the house, for sure. Yeah, it's hard to imagine what might have happened, you know, there's holes all over the place, but I don't know if that was just sort of cautionary, to do a ton of holes and just check it, or if it was really bad, there might have been, you know, a lot of water in the house, I don't know.
I'm just curious as to how the fire department would have known how to approach this.
You know, because people that part.
Yeah.
Oh, yes. Oh, of course, yes.
Yeah, and then I have a few more questions for these guys. Well, in 2018, a straw bale house in Fort Erie caught on fire. I know of one other in the Killaloe area as well. So the Fort Erie fire happened because Fort Erie very windy, and there's a satellite dish that got blown off and left an arcing wire, and then that sparked a fire in the ventilation cavity of the roof assembly, so the roof caught on fire. And then to answer your question, volunteer fire service gets called in, and they don't know anything about straw bale construction, and they misdiagnose what actually are the issues, and they think that they should be whacking the bale walls with sledgehammers to, I don't know, I think they thought that the walls would be burning on the inside, but in fact then they were actually weakening the system because the plaster is the first layer of defense.
And bringing air into the whole thing.
Bringing air into the fire, yes, they did totally the wrong thing, but you also can't blame them because we as an industry haven't educated firefighters and especially volunteer firefighters. So I was called in, kind of like Chris, to assess it and to provide a quote on remediation. But basically, the bale walls were in great shape, aside from where the plaster had been smashed with a sledgehammer. But the inside straw was, I actually talked about this at the AGM some time ago. But yeah, the straw was in great shape. But I think that the way these things tend to go, and maybe this case will be different, it would be nice if it was, is that the straw bale wall just buys the occupants and the fire department time. But because of the hose down, to date, we haven't seen those walls been saved. They end up, it's not just the condition of them, just the way that these things go. They end up, like the whole house basically gets knocked down, is what happens. So that's kind of how it's been going. Maybe it'll be different this time. Yeah, and there's also a really interesting case study on straw bale houses in California in the wildfires of 2017 and how the three houses performed excellently in 3 different scenarios. So sometime when you can't sleep, you could look that up. Yeah. Ben?
Can I offer a?
Yeah.
We had the same experience, we offer a different outcome.
Yeah, okay, great.
And so we had a 1-year-long project that was 6 weeks away from occupancy when electrical fire started inside the Strawdale wall. You were there, I think, right? You were on that site?
I was there after.
After. So similarly, to the example that you were just saying, people smelled something, but they thought that it was somebody doing welding. And for a day, in fact, people smelled something, came back the next day, it was much stronger, and then walking by a wall, felt enormous heat coming off the wall. Then it became clear, there's actually a fire inside the wall, and it had been going on for more than a day at that point, noticeably. And our team did the right thing, called the fire department. I got on the line with the fire chief to try and to prevent them from doing exactly what you described. And it's counter their training. They basically laughed at me to tell them what they should be doing with the wall system. But what I was mostly worried about was water damage, because I knew that they would be able to put the fire out once they created it by opening the wall. And so my aim was to try and get them to go in from the outside and flush it from the outside. They also laughed that off. But what did happen in our particular case, we built that house, and most of our houses are built in the hybrid structural system where there are these box columns. The fire was contained between box columns, and they were able to put it out, on a localized basis. They broke away the plaster to the next set of box columns, and I was able to get them to stop at that. And so the house, it was still 6 months rather than 6 weeks before the owner got to move in, because they had to take down everything that had been burned, and water damage flooded the whole interior, so all the interiors would be ripped out. The building was still structurally sound, there's no other damage elsewhere. But that, for me, was another one of the advantages of the solid box beam system, and that it became a firewall within that wall.
How did the fire start?
It was an electrical fire, but they couldn't determine, the fire inspector could not determine why it happened. There was no evidence of a mark on the wires, and there was, they did this thing called Vega testing or Mega testing, I think, some testing, to see if there had been a factory defect anywhere in the wire that was causing a higher level of resistance. Couldn't find it. So in the end, they don't know why an electrical fire could have started, but that was what it was.
Sorry I just was gonna add one other thing, is how educated is the insurance industry with us coming up with all these fire retardant buildings and products? Is there any incentive that they would review? Like, I used to live in the city. If I get in a standby generator, my insurance dropped because I didn't need freezer protection, I didn't need my cell phone, like, all that stuff. If I'm building a fire retardant home, is the insurance company knowledgeable enough to say, hey, you're saving, where I'm going?
Yeah,
Sorry.
exactly.
Are they not, they're just not into it? Like, you tell them, well, what insulation?
Oh, thank you, yes. Given that we build with Brand Earth and it's fireproof, and I talked to insurance people and explained all this. And when we built our house, we got a really low insurance rate. And I thought, yes, they listened to me, awesome. Turns out it's because the volunteer fire chief lives like a block away. When our clients tried to go to their same insurance company and say, but I've got a Brand Earth house too, why is it my insurance low? They said, no, your volunteer fire department is 4 kilometers farther than we set our limits, and that's why they don't listen.
Well, so that's a long-term goal that we should really be working on for sure. Paula, in the drive back to the airport, she shares stories about people wealthy people wanting to build remotely, timber and straw, and giving up because in the areas of California that they were trying to build in, the insurance, they're just not offering insurance.
Okay.
You know, and they're not making an exception
To
for
any assemblies.
Yeah, to any, that's right,
Yeah.
that's right. But I think if you could show, you know, 16-hour fire rating or, you know, or what, like,
Which is all the more reason to build the straw bale or Randers.
Yeah.
Because you can't get insured in California.
Right, yeah.
So you need your own, insurance, you need your own, Tim, say it,
Yeah.
belt and suspenders.
Right, yes, no, yeah, thank you. So, but no, hey, I don't think that, like, I know it's a long haul, doing fire testing. That's I mean, they talked about it a bit, Anthony and Martin, but really that is the kind of stuff that eventually we do need to get to.
We do need to get to, so if you're talking to firefighters, tell them that Straw Bale Construction, Randers, we are your friends, we are buying you time, we're helping you out. Foam is your foe.
Yeah.
And that's maybe where we can, maybe next year we should have the fire chief here, because if you follow environmental defense, they just did a post about firefighters going to Ottawa and advocating for like foam-free construction, because firefighters can't do anything. They just have to walk away from a house burning, house constructed with foam burning, because otherwise they'll die.
Yeah, we had one, we had a recent ICF quote just went, it was ICF to the eaves.
Yeah,
It was less than 2 years old.
it's a travesty.
Yeah,
Yeah,
people died.
it's disgusting, yeah. How are we doing for time? We got 10 minutes?
Yeah, well, we probably, since everybody needs to, not everybody, whoever hasn't vacated their room needs to vacate their room. And we have the opportunity now to visit the medical center. Sorry? Or the trade show, yes, yeah, that's what I'm going to.
There's not a lot left of the trade show, to be clear, which is fine, you can still go and check it out.
I'm still there.
But lots of-
I'm going to drag Garrett with me. We have the continuing education credits it's per day, so if you need credits for today, sign up. I will do that. We have there should be coffee, and we're back here at 11:15. Yeah, no, you're right, 10:30. Well, let's call it 10:45. Yes.
Okay, so to wrap up, I just want to say thank you to our panelists, and in sort of, to give them the last word in 30 seconds or less. I just want to hear what you're both in very innovative, cutting edge technologies, and I just want to hear what's the single thing that you're most excited about in your industries right now.
Wow, 30 seconds short. Okay. The thing that I'm honestly most excited about is our bio-natural floor. I have a sample of it up in the mini trade shows. That is the floor that is biodegradable. It is the future of our business. That is where all of our flooring will be in the next 10 to 15 years. And I'm so excited about it because no one else has even thought about doing this. And we're so ahead of the game that we're blowing minds left, right, and center, right? So it's so exciting, and it's not just biodegradable, but it's high performing, and it's just work. It's so good. So yeah, that's what I'm excited
And I'm just excited about the big boom that I'm seeing in interest in bio-based materials, and this it feels like it's becoming more mainstream. It's traversing fields, and I'm seeing like sustainable art curating talking about bio-based materials and embodied carbon of art installations, and there's a lot of like really beautiful aesthetics for a lot of new companies that I think goes a big way to mainstream some of these products, and I'm excited to do my little part in there, and excited about the R-value testing. I can't stop talking about it.
All right. See you around.
Oh, yeah.
Um,